Hello, this is Know Your Nodes, a series of videos that explore the building blocks of Modulus 3, the node library. I'm Robert Syrett, and today I'd like to show you a straightforward way of building and thinking about counters. I know this is a little drier than usual, but it's a topic I kind of wish there had been a tutorial for when I first started building sequencers. After all, the easiest way to build a sequencer in Modulus is just to connect a counter to a switch. Don't get me wrong, there's some pretty good counters in the module library, but I remember when I opened them up to try and change them to make them my own, I was utterly confused. And that's because unlike a lot of things in Modulus, which are just kind of processing audio or creating a periodic waveform, this one required some thinking, some logic. So I'm here to show you the logic. How can we make a counter switch from forward to reverse, or go back and forth like a pendulum, or reset on command, or jump to any part of the count? I'm going to go over all of these techniques, and hopefully you can find some creative new uses for them. And again, feel free to check out the timestamps down in the description if you just want to watch a portion of this video. I'm trying to make each segment a little bit more self-contained. A counter is what they call an iterative process in the trades, meaning it's going to be a loop. Let's start this rolling with a sample and hold node. That's going to serve as our memory and a value meter so we can see what the current state of the sample and hold node is. We can see currently the value is 0, and my first trick is to count up to 7 and have it reset. For the rest of the video, when I talk about counting, I'm going to use the 0 to n-1 paradigm. That means when there are 8 steps, it will start with 0 and end at 7. I'm just going to double click or double tap on the input to create a quick expression. It's going to read x less than 7 question mark x plus 1 colon 0. At first this may appear cryptic, but this is an if then else expression. That means you can read it as a sentence. If the value of x is less than 7, then add 1 to x. Otherwise, return 0. And now I'm going to complete the loop. I'm going to run a reverse via from the output of the sample and hold node to the input of the expression node. Let's see if it works by triggering it with a MIDI trigger node. Okay, now what if I want to start with a different number, or end with a different number? Well, I'll just edit my expression and replace the 7 with high for the high number, and 0 with low. Can you guess what low is short for? So with the new expression, h less than high question mark x plus 1 colon low. I will set high to 15 and leave nothing attached to low, which automatically sets it to 0. Now might be a good time to point out that there's a little Z on one of the inputs in the feedback loop. This is where Modulus has made its delay feedback for me. Now, everything works well enough, but it's a good idea to set your own feedback delay so that Modulus doesn't get confused the next time you load up a patch. So I'm going to put the feedback delay right at the start of the loop. Okay, so great. Now I can count from 3 to 37 or -1 to 44. But what if I want to count from 44 to -1? How do I count down? Well, first I'm going to just copy the count up expression and make a few edits. Now it's going to say x greater than low question mark x minus 1 colon high. Translated, that is, if x is greater than the lower value, then remove 1. Otherwise, take it back to the top. I mean, it's the exact opposite of the first statement, so it shouldn't come as any surprise that it does the exact opposite thing. And just a little reminder that when you're sending one value to multiple different places in your patch, a via is a great way to organize things, minimize your editing. I'm also going to use a crossfade node to switch between counting up and down. Let me just turn a MIDI trigger into a toggle, and I guess we need to have a clock to step the count forward, so I'm just going to make one of those and put that in there. Seems like the next logical progression after we know how to count up and then count down is to make something that counts up and then counts down, and then counts up and then counts down, and counts up and counts down. I hope you like a counter with your counter, because that's where we're headed. Kind of the simplest form of a counter is just something that counts from 0 to 1 and then back to 0. There's actually a name for this. It's called a flip-flop. And we are going to put that flip-flop in control of the crossfade that switches back and forth from counting up to counting down. I'll just make another sample and hold with a feedback delay running into a reverse via, and then streamline the if-then-else expression. Then I'm going to group it up with some lights so I know if the flippy-floppy is outputting a 1 or a 0. Now that I have the flip-flop in charge, how do I make it switch back and forth at the right time? And the right time is to switch whenever the count is at the high or the low value. So let's make that expression open paren x equal high, close paren plus, open paren x equal low, close paren. I'll just do a magical little edit here and show you that, okay, yeah, with a simple mux node, you can make a three-way switch. So now you have a up mode, a down mode, and a back and forth auto reverse mode. Okay, around this time, the patch is starting to look pretty hairy, so I'm gonna go back to basics, trim back a bit, so that the next part can be understood more simply. I'm just gonna go back to a simple loop counting up. Currently, the if-then-else expression I'm using resets only when the count reaches its upper limit. But I can create a reset signal by using a crossfade node to interrupt that little logic loop. The logic loop is going to be the A signal in the crossfade node, which is the default. The low value is our reset value, when we're counting up anyway. So I'll plug it into the B input. Then, the C input will be our switch, and the current value of the sample and hold will be swapped out for our lowest value. Of course, we need to trigger the sample and hold, so I'm going to sum the triggers from the step and the reset inputs to the sample and hold gate trigger. There is just one more detail to sort out, and that's making sure that the reset input takes priority over the step input. So what's really going on? We have to make sure that if the gate to the sample and hold is already high because there's a gate being sent to it to move the count forward, then you have to interrupt that, because otherwise it will disregard the reset gate. If we want the count to reset every time we send it a trigger, we're going to have to interrupt that step gate signal so that the sample and hold will trigger with the reset. To do that, I will use an if-then-else expression connected to the sample and hold's trigger input. Timer less than 0.001 question mark 0 colon trigs. So translated, until the timer is 0.001 seconds, return is 0. Then you can go back to your normal trigs, trigs, whatever that is. That's going to be the combination of the step gate and the reset gate. Let me just go into utilities and grab a timer node and connect that timer node to the timer input on my expression. Then I connect the reset trigger to the timer. The combined trigger inputs coming from the add node is connected to the trigs input. Now the step input will always step the counter except when there is a reset trigger. And the reset trigger always resets the count because it can interrupt the signal with a tiny little 0.001 second dip down to 0. I'd just like to point out that we are counting up. We reset to the low value when we're counting up, but if we were counting down, we would reset from the high value. When counting back and forth, you can reset it either way, really depending on what you're going for, which brings me to the next bit. We can really easily adapt this reset mechanism and turn it into a way to instantaneously jump to any particular step in a sequence. Just pick any integer that has one of your steps as a number and plug it right in. 3, the third step, or I guess the fourth step, and -1 counting. In fact, let's just make a randomizer setting. Why not? Instead of a reset, this is going to be a random mode. And in random mode, we use a random node. Makes sense, right? Now, whenever you get a signal, it taps the random. Oh, and I should scale that random so it's between the range of the high and the low. And also make sure that it's an integer, so have it round down with a floor expression. Okay. And if you want to have all these features like reset, jump to a particular step, jump to a random step, you just cascade this process. So you just copy and paste it, put them in a chain, and they'll all work in sequence, interrupting each other. Okay, on the home stretch, time to tidy up again. I'll go back to the simple counter with the count up and the count down direction, and explore the relative of random sequences, the random direction. Or maybe I should say direction probability or something. I'll start by making a knob and calling it direction. Then I'll connect it to a comparing expression that says something like random less than knob. Yeah. But now the direction is flickering super fast because the random node is always changing. So I'll run that through a sample and hold node that is triggered by the same trigger as the step. This way the counter only changes direction when it checks to see what direction it should be going. Alright, so now we have it set up so that if the knob is all the way to the left, we're counting backwards. And if it's turned all the way to the right, we're counting forwards. And if it's somewhere in the middle, there's a weighted chance that it will go forward or backwards with perfectly random right in the middle. Alright, well, I think if you made it this far, you deserve some sort of reward. You definitely deserve my gratitude and thanks for watching. If you like this sort of content, let me know in the comments below. It always cheers me up. Like, subscribe, that's all good stuff too. And as usual, I will leave a link in the description to the Autoreverse forum where you can find all the patches that I use during the course of this video. Thank you very much. Really, honestly. Have a good one.